be discussing on a few problems on that you will be encountering in unit number 2. Okay, let's begin with strain gauge. Okay, so this is a problem that we would have seen in the presentation only. So resistance of a wire strain gauge uses a soft iron wire of small diameter. The gauge factor is plus 4.2. Neglecting the piezoresistive effect, calculate the Poisson's ratio. So they've asked to remove this delta rho by rho value. Once it is removed, then you have the gauge factor and you need only find Poisson's ratio, which can be found by this way, which is 1.6. Okay, the another important type of question that usually comes is based on the Young's modulus type, because Young's modulus is the ratio of stress to strain and of a material, and it's a property of a material. The usual type of problems that comes is something like this. A compressive force is applied to a structural member. The strain is 5 microstrain. Two separate strain gauges are attached to the structural member. One is a nickel wire strain gauge having a gauge factor of minus 12.1. Another is a nichrome having a gauge factor of 2. Calculate the resistance of the gauges after they are strained. The resistance of strain gauges before they are strained is 120 ohms. According to our convention, the tensile stress taken as positive. Okay. So while the compressive stress is taken as negative. So one side of the beam is tensile and this another side of the beam is compressive. Which okay. So based on that, you should take the strain. So strain is epsilon, that is minus 5 into 10 power minus 6, and based on the equation delta R by R divided by delta L by L, or strain equal to gauge factor. And we know what is the gauge. So we know what is the resistance, that is 120, and we know what is the strain, and we know the gauge factor of the nickel. So based on that, you can find what is the difference after strain is 0.26 milliohms. This is an increase of 0.26 in the value of resistance because of the positive sign. The nichrome, the change in the value of resistance is 2 and minus 5.1 10 power minus 6 into 120, and it is negative, shows there's a decrease in the gauge resistance after the strain. Okay, after the stress have been provided on the beam. Okay. Okay, so there is another question that might also come is something like this. So if you see the single strain gauge having a resistance of 120 ohm is mounted on a steel cantilever beam at a distance of 0.15 meters from the free end. Okay, and an unknown force F is applied at the free end, produces a deflection of 12.7 mm at the free end. Change in the gauge resistance is found to be 0.152 ohms. The beam is 0.25 meters long with the width of 20 meters and depth of 3 meters. The Young's modulus is 200 giganewtons per meter square. Calculate the gauge factor. So the moment of inertia of the beam I is equal to, for the cantilever beam, that is single attached beam, is given to 1 by 12 BD cube, breadth and thickness to the cube. So these values are given in the question. When you put it, it will be 45 into 10 power minus 12. It will be 10 power minus square meter to the power 4, because meter cube into meter, that is meter to the power 4. Deflection X is given by F L cube by 3 E by I. I we have calculated, that is the moment of inertia. L cube is the length, F is the force, E is the Young's modulus, and 3 is the constant. So based on that, you can, so you need to determine, and you need to determine the force, right? So X is given, the deflection is given as how much? The deflection is given as 12.7 into 10 power minus 3 meters, mm, no? So 10 power minus 3 meters results in 22 newtons. The bending moment is 0.15 meters from the free end. Okay, so it is 0.15 meters from the free end. So I know what is the distance, and I know what is the force. So force into distance is my moment. Okay, so that will be giving the Newton meter. So 3.3 Newton meter. The stress at 0.15 meter from the free end can be calculated as moment. Okay, the moment divided by the moment of inertia into thickness by 2. So this is the formula. Okay, this formula is from the general mechanics of the problem. Okay, so this formula you should in the position to know. Okay, you should know this is the formula. So stress happens at 0.15 meters from the free end. Okay, so that is at a distance of 0.15 meters. A strain gauge is measuring that stress, no? So that happens at 0.15 meters. and when you, so your measured stress, which is 110 meganewton per meter square. Okay, so sorry, 110 meganewtons per meter squared. So you know what is your bending moment, you know what is your moment of inertia, you know the thickness, and divided by 2 results in 110 meganewton per meter squared. And the strain can be calculated as delta L by L or S by E. Okay, so E equal to S by epsilon. Stress by strain is E, that is Young's modulus. So you can calculate your strain, and then what you need to calculate is you need to calculate your gauge factor. So gauge factor can be determined from 0.152 is the difference that they have given, and 120 is this, and you will get a huge gauge factor of 23. Okay, so this is how you calculate when mechanical aspects are given. So what are the things you need to understand in this problem that we will see? The only thing that you need to understand is this formulation of the conversion of bending moment to stress and moment of inertia deflection formulations. Okay, these are the formula you should be remembering, and sometimes the questions might also come from this section also.